So we're going to start with section 5.1 today. That is using the fundamental identities. So let's go ahead and take a look at example number 1. It says using the identities to evaluate a function. This is more like a review from what we've been doing for a while. It says use the values of secant of u is -3/2 and the tangent of u is greater than 0 to find the values of all 6 trig functions. So remember from before that all students take calculus. That helps us remember which trig function is positive in which quadrant. So let's look at secant first. Secant is the reciprocal to which function? And that would be the cosine function. So the cosine would be the reciprocal of that, which would be a -2/3. So we look at the cosine is negative, and cosine is negative in the second quadrant and in the third quadrant. And it also tells us that tangent is going to be a positive value. So tangent is positive in the first quadrant and the third quadrant. So the overlapping quadrant would be quadrant 3. So our triangle, our nice lovely triangle there, is going to be right there. Okay? And we have cosine is adjacent over hypotenuse, so that is adjacent. Remember the hypotenuse is never negative, so the 2 is negative. And if you quickly do Pythagorean theorem, 2 squared plus b squared is equal to 3 squared. B squared is going to equal 5, so b is the square root of 5. So that is my missing value that we need to be able to have there. So what I do now is go through and write in all sine, cosine, tangent. I always do this in the same order so that I'm doing the same thing every time I do this. And put all my angles in there. A lot of times I forget those. Sorry about that. So sine of this triangle here would be opposite over hypotenuse, which is a -√5/3. Okay. And cosine is, we already know what that is the -2/3. The tangent is opposite over adjacent, and negative divided by negative, of course, is positive since we know it's in quadrant 3, and we know it's already going to be positive. Cosecant, you just take the reciprocal of sine, and it's going to be -3/√5, but of course we cannot have that down there. So by this point, hopefully you've caught on how to do that pretty quickly. A -3√5/5. Secant is just going to be -3/2. And cotangent, let me erase some of this here so I have some more room. The cotangent is going to be 2/√5, but of course we had to rationalize the denominator, so that's going to be multiplied by √5 and √5. We've been doing that for a while, so I'm not going to show those steps, and that goes to that. So there are your 6 trig functions. Question number 2 is simplifying the trig expression. And what we do is we try to get these broken down as far as we can to make it something nice and simple instead of the long and complex. So we have sine of x times cosine squared of x minus sine of x. And what I always look first for is is there a common factor between these guys? And there is a common factor of sine on both of those. If I divide that by sine, I have cosine squared x minus 1 that's left over. Now, with the little green sheet you have, or if you don't have a green sheet, look at your trig identities that you have, and we can see that 1 minus cosine squared of x is equal to sine squared of x, which is almost what we have here. But if you notice, it's not 1 minus cosine squared, it's cosine squared minus 1. So what we've got to do is we've got to flip all that stuff around, and we do that by dividing everything by -1. When you do that, you get the positive cosine squared x, and then the 1 turns into the minus. That's going to equal a negative sine squared. So what happens there is this piece right here turns into a negative sine squared x. And we're going to multiply that with what we have at the beginning of sine. So sine times sine squared would be a negative sine cubed of x. So that long, complicated looking one went to one nice, simple expression there. We're just going to factor these. If I was to tell you to go, let me get to my pen here, factor this, like if this was x squared minus 1, you could easily tell me that's the difference of squares to be x plus 1, x minus 1. So instead of x, we're just going to plug in a trig function, say secant on this one. So secant squared minus 1 is just simply going to be secant plus 1 and secant minus 1. That's all that one is. Okay, that one's easy. Let's get to a little bit harder one here. 4, let's say pretend that's 4x squared plus x minus 3. Okay, if I was to say let's factor that out, you could tell me that that's going to be, what would that be? That'd be, let's say 1 and 3 for the factors of 3, and then 4x and x for 4. So that when we do this here, we say this is a minus and this is a plus, because 4x minus 3x gets you to 1x, and that all works. So now instead of plugging in x, let's take that x and put in tangent for that. Okay? So instead of x, we're just going to say tangent of our angle plus 1, and then for tangent our angle minus 3. And that's all you got to do. A lot of people find it easier to do it in terms of x and then just plug in the function back in for your x when you're done. Okay? Now this last one down here, cosecant squared x minus cotangent of x minus 3. Now the good thing here is we had tangent, and we just had secant, just one trig function, but now all of a sudden we have two different ones. So what we're going to have to do is look on your trig identity sheet, and you can see that cosecant squared of our angle is equal to 1 plus cotangent squared. So instead of writing cosecant squared, let's plug 1 plus cotangent squared into there so that everything matches up the way it needs to be. Oh, we're doing x now, aren't we? And then minus cotangent of x minus 3. Now we can simplify that. Let's do the squared term first. Cotangent squared minus cotangent of x. Now 1 minus 3 is a negative 2. And then we can factor that out just like if it was x squared minus x minus 2. That would factor to cotangent and cotangent. And of course the easy factors of 2 would be 2 and 1. We get to the negative in the middle, so that's going to be a negative, and that will be a positive. So that's how you factor out these expressions. The key thing here, you have to make sure you have one trig function. You can't have two, so you got to change it into one. Simplifying a trig expression. So we want to rewrite in terms of sine and cosine whenever possible. So this is one of those that we did a little bit of practice on towards the end of the last chapter, during the first part of chapter 4. But now we're going to focus a little bit more on these to get more practice with them again. So we want to simplify this down as far as we can. So we have a binomial there. We're going to want to try to make it as small as we can there. So sine, cotangent, and cosine. So we want to change that cotangent to terms of sine and cosine. And cotangent, we know, is cosine over sine. And times that by cosine. So that right there goes to sine of t plus cosine times cosine is cosine squared over sine t. Now in order to add fractions, of course, we have to have a common denominator. So between 1 and sine, our common denominator is going to be sine of t. So the second fraction doesn't get changed at all. 1 times sine is sine, so sine times sine would be sine squared. Combine these guys together to the same denominator, so we just add the numerators together. Sine squared plus cosine squared. And from your identity sheet, sine squared plus cosine squared is 1. And then 1 over sine, of course, is going to give you cosecant of t. So after all that work, it goes down to that very little small thing right there. Okay? So let's go ahead and go to example number 5, adding trig expressions here. So here we just simplified it. Now we're going to add them. It's the same type of thing. We have a big complicated one. We want to try to get it down to one simple term if possible. So here we start with two fractions. So in order to add fractions, of course, you have to have a common denominator. So we have to make sure we include both parts in our denominator. So the 1 plus cosine, sine, and I'm going to leave off the theta there and just put that at the end just to save some room. 1 plus cosine and sine. So we have the 1 plus cosine, so the missing factor was sine. So sine times sine is sine squared. Here the missing factor was 1 plus cosine, so we're going to do cosine times 1 plus cosine. So since these are both the same denominators now, we can go ahead and combine it to one big fraction. 1 plus cosine times sine. I'm going to go ahead and leave that right there for right now until we get that numerator simplified. Sine squared plus, now we want to distribute that, cosine, and cosine times cosine is cosine squared. Now we know from everything that we've been doing is sine squared plus cosine squared would go to just 1. So my numerator just goes to 1 plus cosine. My denominator is still the same. So since all of this can cancel with all that, we can actually reduce those guys out. Those reduce each other to 1s. So we're left with 1 over sine again. And 1 over sine, just like it was before, is still cosecant. So yet again, we simplified that down to from two fractions down to one simple term. And that wraps it up for section 5.1.